A uniform 100 Newton bar is spotted at its end as shown. Where must the fulcrum be placed if a 500 newtons weight at one end balance a 200 weight at another? What is the magnitude of the reaction force exerted on the bar? The first thing is we're going to look at the net forces in the y direction, since we don't have any forces which are acting in the x, and this should balance, they should give us 0. Upward forces, we only have N, which is the reaction force or the normal force on the fulcrum. And then we've got downward forces, which will be subtracting because they're going in the opposite direction, 200, the weight of the bar, and also 500 at one end. Net force is supposed to be equal to 0, and that will be N minus negative 200, negative 100 out to 500, that will be 800. So N is going to give us 800 newtons. Now we are going to look at the net torques, and the net torque is supposed to also give us 0 because this system is in equilibrium. So the clockwise torques and the anti-clockwise torque should be able to balance. So let me first start with the clockwise torques. The torques going in this direction. So if this distance is x and the whole of this bar has got a length of L, then this distance, which is not included here, is going to be what? It's going to be the length minus x. Okay, just the whole length. Remove this and then we're going to find that distance. And therefore the clockwise torque is force times distance, and the force is 500. The distance away from the fixed point is L minus x, and this should be equal to the anti-clockwise torques. So first we have got this, that is going to be what? 200 multiplied by the distance from the fixed point, which is the fulcrum, to be 200 multiplied by x. We also have the weight. Okay, so what is the distance of the weight? Well, the weight, we know this distance. The weight of something always acts on its middle as long as this is a uniform bar. That means the distance here is length over 2. This is the distance up to this point. That's length over 2. Meaning even the rest of the distance that is remaining is also going to be what? Length over 2. But we want a distance from the fulcrum, from this point, for us to be able to find the torque. So if this is length over 2 and this is x up to the fulcrum, what will be this missing distance here? That is the distance that we are interested in. So that will be simply x minus length over 2. So we are going to multiply the force, which is the weight of the bar, which is 100, and then by x minus length over 2. So that is going to be it. And this will give us 500 times L and also 500 times x, being equal to 200 x, and then plus 100 times x minus 100 times L over 2, that will be 50 L. I'm going to take what has got L on one side and what has got x also on one side. So this will be 500 L plus 50 L being equal to 200x plus 100x, and then negative 500x also comes this side, positive 500x. And this is going to give us what? 500L plus 50L, that will be 550L, and that will be equal to 200x plus 100x plus 500x. 200 plus 100, that's 300 plus 50 plus 500, that will be 800x. So I want to remain with x. I'm going to divide both sides by 800. Therefore x is going to be equal to 550 divided by 800, that will be 0.6875 L. So what does this mean? This distance is 0.6875 L. So whatsoever L is, then that will be x. Okay, so this means that x is simply 0.6875. Okay, if this length was taken to be 1 unit, then it will be 1 times that 0.687 0.75, and just like that. So this is the value of x, and we don't know what the unit is. It can be in meters, centimeters, so we can just leave it like that. Well, thank you so much for watching. Enjoy your day.